Hello, good evening guys, welcome back to a new video. And in today's video we are looking to a very interesting and important topic, that is allotropes. Basically this is also a topic related to the solids, because solids do exist as a form of allotropes. You know, if you have got three different states of matter, so the solid furthermore includes some other forms, which include crystals, which include amorphous forms, which include allotropes, which we are studying today, and probably the anisotropic forms, which we'll be studying in the next video. So today's video is about the allotropic forms of solid, or the allotropes. So here the word is allotropes, and the study of the allotropes is termed as a allotropy. Now, if we decode the word, we will find that the altos, the word allotrope, and here altos, that is for other, and the tropia, tropes for tropia, allo means other, and tropes for tropia, other form. So here, other forms or different forms. Now very important thing over here, which will clear all of your concept, is this, that this is uh, limited to elements, pure elements. Like a compound cannot have allotropic forms. Remember this. A compound may have some got isotropic forms, but they would be something else. So which we will be studying our next videos probably. But in today's video we have got uh, forms of solid which are related to a pure element. For suppose, if you have got carbon, so different forms of carbon, which are all called the allotropes. Like we have heard that the diamond is a carbon, the graphite is a carbon, so these both are the same element. These are not compound, or they have got similar elements, so they are probably allotropes. So remember that they have got uh, chemical nature is same, chemical properties are same, because there is a carbon present in the compound, but the physical is not the same. Like if diamond is the hardest while graphite isn't, diamond hasn't got the electrical conductivity while the graphite has. So here comes the difference. First of all, let's look into what are allotropes. So uh, different physical forms in which an element exists. Here the word element is necessary. Different physical forms in which element can exist because of difference in chemical structure. Of course there is arrangement of atoms is different, but the constituent is always a pure element. Like we are probably studying this, I'm not going into that point. You're just looking at the diagram. Next step. Allotropes are matters that are made up of only one type of atom. Again, I said the same point, that if you got the concept that they are limited to pure elements, so your all concept about allotropes would be clear. Now, this is a contrast to other matters such as water, which is combination of one and oxygen and hydrogen. So, okay, so this says that uh, this is in contrast to other atoms. So probably you can understand this point when you are studying the compound forms, compound, we can say compound isotropic forms. Okay, allotrope chemical structure, see that there is a single purple unit inside it, while in water it is in contrast, like it has got blue and red, so there are different atoms, but here we have got the similar atom. This is what allotrope is. While here you're gonna see, first of all, let's see this picture. Here you're gonna see uh, here, let me move it over here. Now here you're gonna see that we have got allotropes of carbon. We cannot see that allotropes of CO2, because allotropes are meant to elements. So in allotropes of carbon we have got coal, we have got diamond, graphite. Here this is graphite. They are correlated, very related. Okay, graphite and diamond are both allotropes of carbon. Like this is the arrangement in the diamond. You're gonna see all there are black dots, and here is the arrangement in graphite. So the atoms are the same, but the arrangement is different. So this is allotrope. Like diamond has got different properties due to this arrangement, while graphite has got different. It is harder, it is harder, more solid, it is more solid, and it is more solid, it is more, it is solid is less. uh, Graphite can conduct electricity due to the hexagonal layer formation. Like over here they have got first layer, we have got second layer. So this case is not the same in the diamond, so diamond is a bad conductor. Similarly, here you're gonna see a better picture. In diamond and graphite, again we have got a comparison. In graphite, I would want to tell you a point that this is the same element which is present in our uh, the pencils which we use. We have got diamond, so you're gonna see the carbon atoms. Both have got the carbon atoms. Thus, just there is a difference in the arrangement. So there are different layers form. First layer, second layer, third layer. In the graphite, hexagonal layers are there which make it a good conductor, while in diamonds the case is not the same, so it is bad conductor of electricity. Similarly, the cube sort of arrangement of the diamond gives it more rigid and strong structure, and it is hardest uh, known substance still, while in graphite the case is not the same. Like the layers are sliding over each other, so they are the graphite is smooth due to this reason. And here we got some other forms, like on not only carbon, graphite and diamond exist, there are other forms as well. Like we have got graphite, we have got diamond, and we have got BC8. We will probably studying in your chemical engineering or your future studies probably. Buckminster fullerenes is they have got ball like arrangement of atoms, like C60 carbon atoms form a single unit of the Buckminster fullerenes, or you can say fullerenes, and it was invented and named upon by the scientist looking over a ball shaped building that was Buckminster fullerenes. And due to the ball like arrangement, it is also called the buckyballs. And we have got nanotube, and we have got graphene, right? And here is the buckyballs arrangement. You know, see that there is a complete web 3D arrangement, and it has got its own properties. So I do hope that you've got the concept of allotropes. If you did, do like the video. Meet you guys in the next video. Till that, goodbye.